I said I would give you a little more information on the exam, which is now a week from Monday. So that's coming up. In terms of like how the exam is going to, be presented, it's a written exam. So you just will need, pencil, calculator probably. And then I think we'll do 2 pages of notes. So like letter paper, front and back. You can put anything on it you want. I will provide you with any like Bessel function tables or things that are like kind of, I think I'll send around, maybe hopefully mid next week, the actual stuff I'm providing for you on the exam, but you shouldn't need to, copy like Bessel function derivatives or things like that. But yeah, any other notes that you want, and if you want to print out your card and put stuff on that, that's fine too. I don't really care what's on the cards or your note sheets, but 2 pages front and back should be enough. All right. What the exam will include, it will be probably 2 problems. It's intended to be about an hour long. So I think we'll start it 5 minutes early. Does anybody have an issue getting here like 5 minutes early? Anybody? Okay. If you aren't comfortable raising your hand, just let me know after class. We could talk about it too. But so we'll start 5 minutes early and end 5 minutes late. Hopefully that'll still give you guys a chance to get to other classes. So yeah, 1 hour, 2 problems, kind of sub parts within each problem. So you might see 2 problems with A, B, and C on them, something like that. What you might be asked to do, right? You might be asked to go through a resistance network and come up with a resistance solution. You might be asked to derive ODEs, state boundary conditions. You might be asked to solve ODEs. So you want to be comfortable with all those things. You won't be asked to do anything that would be like, rated duplicate loop or how would this look in MATLAB or anything like that. However, you could be asked to do something like derive the equations for a numerical solution. You might be asked to, here's my control volume around a node in numerical solution. What are the equations for the energy balance on that? How would I go about writing expressions for that? And you also might be asked things like, can you sketch a plot of temperature profile given these conditions, and not actually solving the problem, but just kind of sketching it based on the given information. And so for those types of things, if you've had 364 before with me in particular, you have done that. But really what I'd be looking for there is, are you capturing like the effects at the boundaries correctly? Is the slope what it should be? Is the curvature of the line what it should be? Like, you don't have to get really super precise, but you should at least have the right features showing up in the graph. Okay, that's just one way we can deal with kind of the exam situation without having you go and solve long problems and plot them. Any questions on the exam? Yeah.
Sorry, just to clarify the number of letter pages. So it's 1 page,
2 full sheets of paper, front and back, so 4 sides of paper. Yeah. I mean, I'd give you more, but if I give you more, I think it wastes your time. So, and I think that should be enough. Yeah. Yeah, good question. I will post some practice exams. I need to go back and I'll probably ask Professor Nellis for some of his old exams and see if I can post them. But yeah, I'll post a few examples at least, and probably some of the solutions with him if he's okay with that. That would be hopefully early next week. I'll do that. Okay, anything else? Yeah.
Based on what you're saying, like material covers.
Yeah, I would say you probably want to be comfortable with everything up through 2D solutions, this superposition, anything that's going to be covered up through the homework that's due next Friday, which is, I think, up through today. Because on Monday, we're going to start talking about transient problems, non-steady state problems, and I'm not going to cover that on the exam. Yeah. No, I don't. I won't ask you to do that. Okay. Okay.